Hello, I'm Richard Neilson and welcome to the National Decommissioning Centre and our recently installed simulation suite. We've partnered with the Offshore Simulator Centre in Norway to provide a unique facility in the northeast of Scotland. The simulator provides us with the capability of undertaking both marine simulation and data modelling, visualisation and decision making. Let me take you around the suite and we'll look at the marine simulation side first. The suite comprises three main areas: the dome, in which we have the real-time controls, the control room and our debriefing room. We'll start in the control room. The main station is where we'll do the initial build of a simulation, setting up the scene and pulling in vessels, cranes, remote operated vehicles or ROVs, and other items from our library in what's termed the sandbox. The other three stations in this room allow other staff to interact with or modify the simulation in real time, while people are performing tasks or operations in the same scene within the dome. For example, during a simulation, the sea state could be modified to see the effect of this during the operation. Across from these stations, we have the debriefing room, where we can analyse and rerun simulations to allow the team to discuss the outcomes. If we need to present to more people, we can export the output to our 6-metre screen in our hub area. Moving into the dome, we have the main display and real-time control area. This contains 4 individual control stations, 2 for controlling vessels and 2 which control either cranes or ROVs. The controls on these stations interact with the simulation in real time, allowing the user to perform the required operations and see the results. This allows us to trial operations or new technologies in a safe virtual environment, simulating all of the physics in real time before deploying them in real life. Because we have 2 vessel and 2 control stations, we can simulate complex operations with multiple vessels and cranes or remote operated vehicles. An example might be a twin vessel lift of a topside. This clip shows the ability to build a simulation and to bring new items into the scene in real time. In this case, a semi-submersible crane vessel, or SSZV, with 2 cranes is brought into the scene. This vessel can then be driven into close proximity to the asset and the cranes deployed. We can then add in another crane vessel and deploy the cranes and set up the hooks for the lift. We then add in the cable connections to the topside and then undertake the lift itself. At this point, we move the crane vessels away and add a barge onto which we can lift the topside. Again, we can introduce this in real time, allowing us to complete the operation. If we wanted to, we could then swap the vessel control to tug or anchor handler to tow the topside to shore. We've also partnered with Axelos to provide a structural analysis capability for the simulator, and we'll be providing more information on that in the near future. I mentioned earlier that as well as marine simulation, we can use the simulator as a tool to visualise datasets and model the interactions between them to allow us to make better decisions. This will allow us to look at possible benefits of campaigns for decommissioning, how to go about decommissioning as we move to a net zero environment, and some of the big challenges around energy transition and integration. Our priority project, which we've called Smart Basin, is to build a virtual model of the entire North Sea. Our aim is to map all the offshore assets, including oil and gas and renewables. For this, we'll draw on data from databases like the Oil and Gas Authority's National Data Repository. Once these are in place, we can overlay data, including likely cessation of production dates for oil and gas assets, dates when renewable power will come online and the scale of these resources, possible carbon capture and storage systems, etc. We'll then be able to model the interaction between these and help stakeholders and decision makers in assessing the best options. We'll start with an exemplar area either east of Shetland or the southern North Sea. East of Shetland is of interest as there is the potential for optimising decommissioning and looking at interaction with the Norwegian sector. The southern North Sea is interesting because of the proximity between ageing oil and gas infrastructure and renewable energy resources, and the possibility of repurposing of some of the oil and gas assets to renewable hubs. We've started collecting data about these assets to initiate the build. To demonstrate the possibilities on a more accessible scale, we've built a model of Aberdeen and are starting to collect data which can be superimposed on it. Our first piece of work around this will be a collaborative study with the City Council and Aberdeen Harbour Board of any changes in traffic flow caused by a new south basin of the harbour and the effects of different link roads. I hope this has been of interest and we look forward to discussing new projects soon.